Okay, so I am now recording the lab after I just finished it, and I will be going over the steps for everything that was asked of me during the lab, which are writing data from the switches to a data register, reading the data from a data register, transferring the data from one data register to another, and transferring the data from a data register to the data output register and LED. First off, for writing the data, we need to make sure that we're going to be doing register B for writing the data. We're going to write the data register B. So we're going to change the switches so that they match the data listed under the write register data table for register B. And the data for register B is 00001111, meaning switches D0 through D3 need to be turned on, while the other switches D4 through D7 need to be turned off, which I have already done here. Next, we will toggle the data in clock state from 0 to 1 and back to 0 to read the data from the switches. Then we will toggle the data to bus pin from 1 to 0, and this will display the data at the top here with these data bus pins. And as mentioned earlier with the binary code, just like the switches, D0 through D3 are turned on, while D4 through D7 are turned off, like we want. Next, we need to write the data to register B. First, we need to make sure that the address of the write decoder is set to address B. A0 needs to be set to 1. A1 needs to be set to 0. Then we need to write. After writing the data, or setting the address for writing the data, we need to write the data itself. To do this, we will toggle the state of memwr from 1 to 0 and back to 1. Then toggle data to bus from 0 back to 1 just to make sure nothing goes wrong. This will write the data that we just read from the switches to register B. The next thing we are asked to do is write the data. Not write the data, but read the data that we just written into register B. To do this, we need to change the read address to that of register B, which is the same as the write address, so A1 needs to be 0, A0 needs to be 1. And then we will toggle MRD from 1 to 0, and it will display the data from register B at the top here with these pins. D0 through D3 are on, D4 through D7 are off, which matches the binary code from before, 00001111. So the data has been read and has been written to register B properly. And we can do the same for the other registers as well. Change AORD to 0 and we get the value at A, 00000011, 00000011. We turn C on, we change A1 to 1 and we get C, 00111111, 00111111. And then if we change it to D, by changing A0 to 1 state, all the lights are on, which matches the 11111111 data associated with D. Let's go ahead and turn that off. Next, the third thing it asks is to transfer the data from one register to another. I will be going through which the registers that ask us to transfer between are register A to register C and register D to register B. To do this, start off by changing the address to the one you are going to be transferring from. Since it's A to C, we'll be changing this to address A. Since it's C, we're going to change this to address C. Then read the data from the register that you are going to be transferring from. Toggle MRD from 1 to 0 back to 1. You'll read the data from A. Then we need to write the data to C, which again we already have it set up here, 0 and 1, the data of C. A is 0 is 0, A of 1 is 1, so it's C. Then toggle memwr from 1 to 0 back to 1 to write the data that we just read from A into C. If we read the data from A, it will display the data from A, and if we toggle it to C, the data of C now matches the data of A. The other one it asks us to do is change the data from D to the data of B. And we will, to first off, change the address data for reading to the address of D, 1, 1, and change the data for writing, data of B, 0, 1. Read the data from D by toggling MRD on from 0, then back to 1, and then change memwr to 0 and back to 1 to write the data to B. And then we can read the data at D. All lights are on. If we change it to B, all lights are still on, so the data from D has been transferred to B. Then lastly, the final thing is transfer the data in register A to the output data register and display it on the LEDs. To do this, we change the address to that of A, 0, 0, change MRD from 1 to 0, which will send the data from the data register, which will read the data from the data register, and also show it in the data bus. And then we will toggle the data from bus clock pin on the data output register from the 0 state to 1, and it will change the LEDs to match the LEDs of A. D0 and D1 are on, D2 through D7 are off. Then change it from 0 back to 1, and MRD from 0 to 1. And I just realized that I said that we needed to change data from bus from 0 back to 1, but I meant to say 1 back to 0. So again, let's go over it again in case I confuse anyone. To read data, change MRD from 1 to the address you want to read it from, then toggle it on from 1 to 0, then change data from bus from 0 to 1, and it will read the data, change it from 1 back to 0 to stop reading the data, and then change this from 0 back to 1, and your LED should match the lights or the data of A, which again, if I turn this back to 0, the data does match as D and 0 and D1 are on, while D2 through D7 are all off. That was everything that we did in the lab. So thank you, and I hope this helps you understand what I did during the given lab. Thank you, and bye.